In this lesson, we're going to write the equation for a quadratic function given a graph. So here we're given two graphs, and we're asked to write the equation for this quadratic function. So notice we have two parabolas, so they're obviously quadratic functions. To see if there were any stretches or compressions that's been done to the graph, let's take a look at 2 points that we know to be on the parent function of the quadratic function. So if you start at the vertex and you go over 1 and up 1, okay, it's there. Again, over 1, up 1 on the other side. So this particular graph of the parent function, the only thing that was done to it was a both horizontal and vertical shifting there, no stretches or compressions. Let's take a look at the other one. So into the second one, if we go over 1 and then down, over and down. Okay, so we can see that both of these are just simply the parent function that has either a horizontal or vertical shift or both. So let's take a look at our vertex form here, and starting with, and again, we just established just now that there is not going to be a value outside because there were no stretches or compression. Otherwise, you'd see a number out here. So with the first example here, you will see nothing, which indicates that it's positive. Next, horizontally, we want to know how the graph was shift, or if it was shift horizontally. So you know that the parent function of the quadratic starts at the point of origin there, the vertex. So we can see that it was moved over 1, 2, 3, 4, 5 units. So when you move over 5, remember horizontal is opposite what it seems. So even though you're moving over to the positive side, it's going to be x minus h, because that indicates the number is positive. So that's going to be x minus 5. And then the graph also went down for 1, 2, 3, 4. That's a vertical shift, which we're going to write in the back. So when we put it all together, the first function is going to be f of x equals x minus 5 squared minus 4. All right, let's take a look at the second example. And as you can see, this is a parabola that is opening downward, which indicates that the value outside must be a negative because it was flipped across the x-axis. Again, there was no stretching or compression, so it would just simply be a negative out front. Now let's move on to our horizontal shift. Yes, it has shifted from its original point. So as you can see, it was only shifted over 1 unit. So when we move to the left, recall that is going to be a positive there. So it's going to be x plus 1. Our graph was also shifted down vertically 1, 2, 3 units, and that will go in the back where you see K. So when we put it all together, this is the line of that equation. F of x equals negative x plus 1 squared minus 3. And there you have it, writing quadratic functions. The next thing we're going to do is write quadratic functions when we're given the vertex and a point. So on the graph, the only thing that we're going to be given is just the vertex and one other point on that parabola, and asked to write an equation for that particular parabola. So here that we're given the vertex at 2, negative 1, and another point on the graph is 0, 0. So to find or to write that equation, you're going to use the vertex form to plug your values in. So you're going to plug your ordered pair that you were given in the front, and you're going to plug your vertex in the back. So here's what I mean. You know that f of x is the same thing as y, so you're going to plug in the y value of your ordered pair there. You're going to plug in the x value of your ordered pair here. And recall HK is your vertex, H is the x value of your vertex, and K being the y value of your vertex. So when we plug those values in, it's going to look like so. Let's do the math so that we can solve for A. First of all, let's take a look at our graph, because A would be a vertical stretch or compression if it's a numerical value there. So recall that the parent function itself would be moved over 1 unit. So over 1, up 1. Notice it is not there. Over 1, up 1. So it looks like the graph we have is wider than the parent function. So what that means is we can expect to have a fraction which represents a compression, a vertical compression of this graph where it was pushed down toward the x-axis. But let's go ahead and do the math and see. So -2 squared equals 4. 4 times a is 4a. Our next step to solving for a is to add 1 to each side, then divide by 4, and a equals 1/4. So sure enough, just as we suspected, it was going to be a fraction there which represented that was a vertical compression. So when we put it all together, our line then is going to be f of x equals 1/4 times x minus 2 squared minus 1. And there you have it, quadratic functions, writing quadratic functions. Okay, let's do one more. Here we're given again the vertex and one other point on the graph, and asked to write an equation for that, or write a function. Notice that this particular parabola is more narrow than the parent function, which indicates that there was a vertical stretching of that graph. So we can expect for the a value to be a whole number and not a fraction. Also, if you look at the parabola, it opens downward, which means that it was reflected about the x-axis, so that number is going to be a negative number. Okay, so a negative whole number. All right, so let's go ahead and plug in those values into the vertex form, and let's see what a is. So remember, your ordered pair point is going to be in the front, your vertex is going to be in the back in their respective places. So once we plug that in, it's going to look like so. Let's go ahead and do the math. Inside the parentheses, we have 3 take away 1, which is 2. 2 squared is going to be 4. 4 times a is 4a. Next step is to subtract 2 from each side, then divide by 4, and a equals -2. So just as we suspected, that it was going to be a whole number, not a fraction, and it also was going to be a negative because it was reflected about the x-axis. And so we have our line. Putting it all together, it's going to look like so. And there you have it, writing quadratic functions. Okay, that's it for this video. Thank you for watching MVP tutorials created by your instructor, Dr. Speights. Please feel free to like, share, and subscribe. Goodbye for now. I hope you'll join me in the next video.